Hello, my name is Nathan, and I'm back with question number 3 on this practice midterm number 2 for Physics 457. So for this question, Dr. Donev asks us to rederive the wave equation, not for E like we did in class, our electric field, but for our magnetic field, so B. So on the left here, I've written out some vector identities and Maxwell's equations from the formula sheet that are going to be useful for this derivation. So to start out, I'm going to take this formula right here. So I'm going to take the curl of B is equal to mu naught J plus epsilon naught dE dt. And I'm going to start out by taking the curl of both sides. So I'm taking the curl of B is equal to mu naught times J plus epsilon naught dE dt. And now I'm looking for, oh, sorry, I forgot my curl. The curl of that. So I'm looking for ways to simplify this equation now. So because Dr. Donev states that this is in space, we can assume that this is in a vacuum. And in a vacuum, we're not going to have any current density. So this is going to go to 0 here. We also have a vector identity for this, which I've written down here. So I'm going to apply this vector identity to get the divergence of, not A this time, we're looking at B, is equal to, oh, I'm sorry, I forgot my second half of that, minus the Laplacian of A, which is equal to mu naught curl of dE dt. So unless it's February 14th, Valentine's Day, we know that this divergence of the magnetic field is going to go to 0 because we can't have a magnetic monopole. I'm just going to switch markers here. And because this is a special case like we discussed in class, this derivative here can be brought outside of our curl. So we're going to end up with negative Laplacian of A. Oh, I missed that. That should be a B. I was copying down the equation too closely, which means that this is going to be a B. That's equal to mu naught times d dt of the curl of E. And for our next step, oh, and I dropped an E. I'm missing a few things this time. So an E naught, that comes out and goes here, so we're keeping track of our constants. And now we can see that this matches up with this Maxwell's equation here. So we can replace the curl of E with the time derivative, negative time derivative of B. So then we get epsilon naught, mu naught times D, that now it's going to be squared since we've got the double time derivative of B, and we bring out the negative. So we've got essentially the wave equation once we rewrite this. We also know that epsilon naught mu naught is equal to B, or 1 over c squared. 1 over c squared. So that's exactly what we would expect. A wave traveling along with our B fields traveling at c squared. So that's question number 3 on the practice midterm, and I'll see you again for question number 4.